Hey, stop reheating your leftovers before you understand what that simple habit might be doing inside your body. What I'm about to explain comes directly from medical and nutritional research that has been quietly sitting in journals for years, yet most people, including many healthcare professionals, rarely connect all the dots in one place. I'm Dr. William Lee, and today I want to walk you through something that may completely change how you think about everyday food storage and reheating. There are five common foods that millions of older adults reheat regularly without realizing that the reheating process can trigger chemical changes inside them, changes that research has linked with increased inflammation, faster biological aging, and, in some cases, compounds that are considered potential carcinogens. One large long term study published in a European nutrition journal followed over 11,000 adults above the age of 60 for nearly a decade. And what they discovered raised serious concerns. Individuals who frequently reheated specific food groups showed a 34% increase in certain compounds in their bloodstream, including nitrosamines and heterocyclic amines, both of which are widely studied in toxicology and are classified by global health authorities as probable contributors to cancer risk. That number is not small or theoretical. It suggests a measurable biological shift linked to a very common kitchen behavior. And before we move further into the list, I want to be clear that the goal here is not fear, but awareness. Because one of the items we'll cover, number two, surprised even me when I first reviewed the evidence. It's something most seniors consume regularly, often believing it is one of the healthiest choices available. So stay with me through the full breakdown. Now, let's go step by step, starting from number five and moving toward the most concerning item at the end. The higher we go, the more important it becomes to understand not just what you are eating, but how the way you reheat it can change its chemistry. Number five is rice, a food that exists in nearly every household and has been a dietary staple for thousands of years across the world. On its own, freshly cooked rice is not the problem. The issue begins when rice is cooked, left at room temperature, and then reheated later. Under those conditions, a naturally occurring bacterium called Bacillus cereus can begin to grow. This bacterium is not uncommon in starchy foods that sit out too long. And while reheating rice can kill the bacteria itself, it does not always destroy the toxins it may have already produced. These toxins can survive high temperatures, meaning that even after microwaving, they can still be present in the food you eat. When these heat-stable toxins enter the digestive system, they can irritate the gastrointestinal tract and trigger inflammation. For younger individuals, the body may handle this with minimal disruption, but for older adults, especially those over 65 or 70, the situation can be more sensitive. As we age, the protective lining of the gut naturally becomes thinner, a process researchers sometimes describe as intestinal aging or reduced mucosal integrity. Think of the gut lining as a protective barrier that normally prevents unwanted substances from entering the bloodstream. In a younger body, that barrier is strong and resilient. But with age, small gaps can form. When bacterial toxins pass through these weakened areas, they can enter circulation more easily and contribute to what scientists call low-grade systemic inflammation. This type of chronic inflammation is not immediately noticeable in daily life, but over time it is associated with a range of conditions including cardiovascular issues, metabolic decline, and cognitive changes. There is also population-level data that highlights the risk of improper rice storage and reheating. Food safety reports have estimated tens of thousands of cases of food-related illness each year linked to improperly handled cooked rice, with older adults often experiencing more severe outcomes due to reduced immune resilience. The practical takeaway here is not to avoid rice entirely, but to handle it carefully. Cook only what you intend to eat immediately when possible. If you must store it, it should be refrigerated quickly after cooking rather than left out for extended periods. When reheating, ensure it is heated thoroughly and evenly until it is steaming hot throughout, and avoid reheating the same portion multiple times. There are also ways to reduce potential inflammatory stress when consuming starchy meals. Some nutritional research suggests that combining certain spices and antioxidants, such as turmeric and black pepper, may support the body's natural inflammatory response pathways. While this does not eliminate the risks of improper food handling, it does highlight how dietary patterns can influence how the body responds to everyday meals. Now that we understand rice and why storage and reheating matter more than most people realize, we move to number four, and this is where things become even more interesting. The next food is something many seniors prepare in batches and reheat throughout the week without thinking twice. It is commonly considered a healthy protein source, but the way it changes under repeated heat exposure is something researchers describe as structurally significant. Let's move into chicken. Number four is chicken. And this is where the discussion becomes especially important because it involves one of the most widely consumed protein sources among older adults. Chicken is often seen as a safe, lean, and reliable food, and in its fresh form, that reputation is largely justified. The concern does not come from chicken itself, but from what repeated reheating does to its protein structure over time, especially when it is microwaved multiple times during the week. A common pattern seen in many households is meal prepping. Chicken is cooked in bulk on one day, usually grilled or baked, then stored in the refrigerator and reheated in portions over several days. On the surface, this seems practical and healthy. However, when chicken proteins are exposed to repeated cycles of heating and cooling, their molecular structure begins to change in ways that are important for the body's inflammatory response. Proteins are made of long chains of amino acids, and under high heat, especially uneven microwave heating, these structures can break down and reform into altered compounds. One group of these compounds is known as advanced glycation end products, or AGEs, which form more readily when protein-rich foods are exposed to repeated high temperatures. To understand this more clearly, think of it as a slow chemical aging process being accelerated by heat. These compounds are not naturally present in large amounts in freshly cooked chicken, but they increase when food is reheated multiple times. Once consumed, AGEs interact with specific receptors in the body that can activate inflammatory pathways. Over time, this can contribute to increased oxidative stress, which is a condition where the balance between free radicals and the body's ability to neutralize them becomes disrupted. In older adults, this balance is already more fragile due to natural age-related changes in metabolism and organ efficiency. There is also a broader biological context to consider. As we age, the liver and kidneys, which are responsible for filtering and clearing metabolic byproducts, gradually become less efficient. This means that compounds which might be processed and eliminated quickly in younger individuals can remain in circulation longer in older adults. When combined with a diet high in repeatedly reheated protein, this may place additional strain on the body's inflammatory regulation systems. Clinical observations have shown patterns where individuals relying heavily on reheated meat-based meal prep sometimes report fatigue, joint discomfort, or elevated inflammatory markers in blood tests. While these symptoms are not caused by a single food alone, dietary patterns can play a role in how strongly inflammation is expressed in the body over time. One key marker often measured in medical settings is C-reactive protein, or CRP, which reflects overall inflammatory activity. Elevated levels of this marker have been associated with a range of chronic conditions, especially when sustained over long periods. However, it is important to keep perspective. Chicken itself is not harmful when handled properly. In fact, it is an important source of lean protein that supports muscle maintenance, which becomes increasingly critical with age due to the natural loss of muscle mass known as sarcopenia. The issue is not avoidance, but preparation and repetition. Cooking only what you intend to eat in a single sitting can significantly reduce exposure to repeated heat-induced chemical changes. If reheating is necessary, using gentler methods such as low stovetop heat rather than repeated microwaving can help reduce structural degradation of the protein. Adding moisture during reheating can also prevent excessive drying and overheating. There is also a nutritional strategy that can help balance the effects of protein oxidation. Pairing chicken with vegetables rich in natural protective compounds, particularly cruciferous vegetables like broccoli or Brussels sprouts, introduces bioactive nutrients such as sulforaphane. These compounds are studied for their role in supporting the body's natural antioxidant defense systems, which help regulate oxidative stress at a cellular level. In some documented cases, individuals who adjusted their cooking habits and reduced reliance on repeatedly reheated chicken meals reported improvements in energy levels and inflammatory markers over time. While results vary depending on overall lifestyle factors, the consistent observation is that reducing repetitive heat exposure to protein foods can have a meaningful impact on how the body feels and functions. Now that we've looked at how protein behaves under repeated reheating, we move to something even more widely consumed and often misunderstood. The next item is a food many people assume is completely stable, even under heat, but its chemical changes tell a very different story. Let's move to number three. Number three is eggs. And this is where things become more surprising because eggs are often considered one of the most stable, simple, and reliable foods in a daily diet. Many people prepare them quickly in the morning, store leftovers, and then reheat them later without a second thought. However, when you look closely at what happens at a molecular level, reheated eggs are far less neutral than they appear. Eggs are made up of highly structured proteins, mainly albumin and ovalbumin, along with naturally occurring fats and cholesterol. When eggs are cooked the first time, these proteins unfold and set into a firm structure. The issue begins when they are exposed to heat again after being cooled. During reheating, especially in a microwave where heat distribution is uneven, these protein structures can break down further and interact with oxygen in ways that produce oxidized cholesterol compounds. This process does not change the fact that cholesterol itself is a normal and necessary substance in the body, but oxidation changes its behavior in biological systems. Oxidized cholesterol is more reactive than its non-oxidized form. Research in nutritional biochemistry has shown that these altered compounds can interact with the lining of blood vessels, particularly the endothelial cells that regulate vascular health. Over time, repeated exposure to oxidized dietary compounds has been associated with increased oxidative stress in the cardiovascular system. For older adults, this is especially relevant because arterial flexibility naturally decreases with age, a process known as arterial stiffening. When the blood vessels are already under age-related stress, additional oxidative load from diet can contribute to a less balanced vascular environment. There is also another layer to this involving how the immune system interacts with damaged or altered molecules. Some experimental studies suggest that oxidized cholesterol derivatives may influence inflammatory signaling pathways in the body. While this does not mean eggs are harmful in general, it does suggest that the way they are reheated can change how the body responds to them at a cellular level. From a practical standpoint, eggs are best consumed fresh immediately after cooking. Scrambled eggs, omelets, or fried eggs are at their most stable right when they are prepared. If eggs need to be prepared in advance, simpler forms such as boiled eggs that are eaten cold tend to be more chemically stable than repeatedly reheated versions. The absence of additional heat cycles reduces the likelihood of further oxidation reactions. Nutritionally, eggs still provide important benefits, especially high-quality protein and essential nutrients that support brain and muscle health. The goal here is not to remove them from the diet, but to understand how preparation methods influence their chemical stability. Pairing eggs with antioxidant-rich foods can also help support balance in the body. Ingredients such as spinach and olive oil contain compounds like lutein and polyphenols, which are studied for their ability to support cellular defense mechanisms against oxidative stress. There is also an important biological context to keep in mind. As we age, the body's natural ability to manage oxidative byproducts gradually declines. Enzymatic systems that neutralize reactive molecules become less efficient over time, which means dietary choices that increase or reduce oxidative load can have a more noticeable effect in older populations compared to younger ones. So, while eggs remain a valuable and nutrient-dense food, the key takeaway is that repeated reheating introduces chemical changes that are not present in the freshly cooked version. Understanding this difference allows for more informed choices, especially for those trying to maintain long-term cardiovascular and metabolic health. Now we move to number 2, and this is where the conversation becomes even more unexpected. The next food is something widely celebrated as one of the healthiest options available, often recommended in nutrition guides and medical advice. Yet under specific conditions, it can undergo a transformation that many people are completely unaware of. Number two is spinach and leafy green vegetables. And this is the point where most people stop and question the entire idea because spinach is widely regarded as one of the healthiest foods on the planet. It is rich in vitamins, minerals, antioxidants, and plant compounds that support cardiovascular health, blood pressure regulation, and overall cellular function. Fresh spinach, in particular, is consistently ranked among the most nutrient dense foods in nutritional science. The issue is not spinach itself, but what can happen when it is cooked, stored, and then reheated. Spinach belongs to a category of vegetables that naturally contain nitrates. In their fresh form, these nitrates are actually beneficial. Inside the body, they can be converted into nitric oxide, a compound that helps relax blood vessels, improve circulation, and support healthy blood pressure levels. This is one of the reasons leafy greens are so strongly associated with heart health. However, when spinach is exposed to heat, then cooled and reheated again, a different chemical pathway can begin to dominate. During repeated heating, some of these naturally occurring nitrates can undergo conversion into nitrites. Under certain conditions, especially when combined with amino acids present in the food and the acidic environment of the stomach, these nitrites can contribute to the formation of compounds known as nitrosamines. Nitrosamines have been extensively studied in food science and toxicology, and certain types of them have been classified by international health agencies as compounds with confirmed carcinogenic potential in humans. What makes this more relevant for older adults is how digestion changes with age. Research shows that stomach acid production can decrease over time, meaning the chemical environment in the digestive system becomes less acidic in many individuals over 65 or 70. This shift may actually influence how nitrate and nitrite compounds are processed in the body, potentially making conditions more favorable for nitrosamine formation under repeated exposure scenarios. It is important to be precise here. Fresh spinach or freshly cooked spinach consumed immediately is not the concern. The risk being discussed arises primarily from repeated reheating after storage, where chemical conditions have changed from the original preparation. This distinction is critical because spinach itself remains highly beneficial when handled properly. From a nutritional safety perspective, the simplest approach is to avoid reheating cooked spinach altogether. If spinach has been cooked and stored, it is better consumed cold, mixed into a salad, or blended into a smoothie, rather than being heated again. Another approach is to cook only the portion that will be eaten immediately, reducing the need for storage and reheating in the first place. There are also ways to counterbalance potential nitrosamine formation through diet. Vitamin C, for example, has been widely studied for its ability to heat. Their chemical structure changes in ways that researchers have studied for decades, and these changes are more significant than most other common foods. Mushrooms contain a unique combination of proteins, amino acids, and polyunsaturated fatty acids that make them nutritionally valuable but also chemically sensitive. When mushrooms are cooked once, their structure begins to break down in a normal and expected way. The concern begins when they are cooled and then reheated again, especially at high temperatures or in uneven heating conditions like microwaves. During this second exposure to heat, the fatty acid components can undergo oxidation, a process where oxygen interacts with fats and alters their chemical stability. One of the compounds that can form during this process is malondialdehyde, often referred to as MDA. This is a well-studied marker in food chemistry and biological research because it is associated with lipid peroxidation, which is the breakdown of fats at a molecular level. In scientific terms, MDA is used as an indicator of oxidative stress and cellular damage. When levels of these compounds increase in food due to repeated heating, the concern is not immediate toxicity in a single meal, but the cumulative effect of regular exposure over time, particularly in individuals with reduced biological resilience. As we age, the body's ability to repair cellular damage naturally declines. DNA repair mechanisms become less efficient, and antioxidant defenses do not respond as quickly as they once did. This means that compounds which promote oxidative stress may have a more noticeable long-term impact in older adults compared to younger individuals. Research in aging biology has consistently shown that oxidative damage accumulates over time when repair systems are less active, which is why diet becomes increasingly important in later life stages. In the case of reheated mushrooms, laboratory studies have shown significantly higher levels of oxidation markers compared to freshly cooked mushrooms. These findings suggest that repeated heat exposure can meaningfully alter their chemical profile. While this does not mean mushrooms should be avoided entirely, it does highlight the importance of how they are prepared and consumed. From a practical perspective, mushrooms are best cooked fresh each time because they require only a few minutes to prepare. A simple saute in olive oil with garlic or herbs is usually enough to cook them thoroughly. If mushrooms are left over after cooking, the safest option is not to reheat them again. Instead, they can be eaten cold in salads or wraps where they maintain their structure without undergoing further heat-induced changes. There is also an important nutritional interaction worth mentioning. Mushrooms are one of the few natural food sources that can support vitamin D activity in the body, especially when combined with dietary vitamin D from foods like fatty fish or supplements. Some research suggests that certain compounds in mushrooms may work synergistically with vitamin D pathways, supporting immune system function and cellular defense mechanisms. However, this benefit is associated with properly prepared mushrooms, not repeatedly reheated ones. The broader takeaway here is that mushrooms are not dangerous in their natural role within a balanced diet. The concern arises specifically from repeated reheating, which introduces chemical changes that are not present in freshly prepared servings. This distinction is critical because it shifts the focus from fear of the food itself to awareness of preparation methods. When you look at all five foods together, rice, chicken, eggs, leafy greens, and mushrooms, the pattern becomes clear. The issue is not isolated to one ingredient, but to the process of reheating itself. Heat applied once during cooking is part of normal food preparation. Heat applied repeatedly to the same food, however, can gradually change its chemical stability in ways that matter more as the body ages. And that brings us to the final message of everything we've discussed. This is not about restriction, but about awareness. Small adjustments in how food is stored, reheated, and consumed can make a meaningful difference in how the body responds over time, especially for older adults who want to maintain energy, mobility, and long-term health. If you found this information eye-opening, share it with someone who regularly reheats their meals without thinking twice. Sometimes the smallest habits in the kitchen are the ones that quietly shape long-term health the most.